Hey everybody, today we have a ceiling function. It's the ceiling of a cube root function. And I just want to work with a concrete example here, a numerical example. Let's say we were looking at the cubed root of maybe the cube root of maybe 230 or whatever, 221, let's say. Now, notice this is very close to a perfect cube. 6 cubed is equal to 216, right? So 221 is a little bigger, right? And so that would mean you would have to bump up to the next integer. So this would be equal to 7. All right, and that's basically because 6 cubed is less than 221. Okay, is less than 7 cubed, of course. Okay, so we don't have to know what 7 cubed is, do we? But we know that 221 is between 6 cubed and 7 cubed. Okay, so we can leave it that way. All right, so that's just kind of a refresher. These two definitions are equivalent in the sense that this is just tailor fit. If you look at this definition and realize where the input is the cube root function, this follows fairly quickly. Okay, so let's move along. Now, another thing to note, and by the way, y'all know x would not be equal to 0 here, so we're not worried about 0 being a solution. Not that you necessarily have to mention that, but if you put 0 in right here, you get 0 is equal to 31 false, right? So 0 is certainly not a solution. Now, what I've done right here for you is just, if x happens to be less than 0, then the ceiling function of the cube root function is going to be less than 0, but this guy is going to be positive, and that's clear, right? If you put a negative number in here, so you see there are no solutions. No solutions clearly. No solutions if x is less than 0, right? So we're going to start with positive values, okay? Positive values. Now, the ceiling function always returns an integer, so the very first positive integer is 1. All right, and so it immediately, this is just all cut and dry. This is straight from the definition right here. The cube root of a value x has a ceiling of 1 if and only if x is between 0 and 1, and that's not too hard to anticipate, right? All right, and so that means we would have to set 1 equal to the right-hand side. Okay, remember, here's our original equation up here. Okay, so we have to set 1 equals to this and see what pops out. When we do that, we get 30 over 4, right? But 30 over 4 is certainly greater than 1, right? So it's not in this solution interval. So there's no solution for the ceiling equals 1. So no solution right here. Okay, now let's move along to the next. You see we're just moving methodically along. The ceiling of the cube root of x is equal to 2 implies that x has to be between 1 and 8. Notice that 8 is 2 cubed, right? Okay, but what does that mean? That means we have to set the right-hand side of our equation minus 4x plus 31 equal to 2. Notice up here we set it equal to 1. Here we have to set it equal to 2. Y'all, when you solve this, that's 4x is equal to 29. So this implies that x is equal to 29 over 4. You can almost just see that by inspection. So x equals to 29 over 4. By inspection are just the 2 steps of algebra. Okay, so that is a solution. Now, I'll go ahead and circle it, but you may be wondering, well, why don't we go check out 3? We could do the very same thing. We could set the ceiling of the cube root function equal to 3. But notice right here that this piece right here would imply, I hope I can keep this on the same screen, and maybe, but this condition right here, 4x plus 31, let me just write it down. Right here, I'll write it just right down here, folks. So minus 4x plus 31 is less than 0, right? Less than or equal to 0. Okay, when x is greater than 31 over 4. And that's clear too, isn't it, folks, by inspection? If x is greater than or equal to 31 over 4, which is a number less than, what is that, 7 times 4, 31 over 4, what do we get there? But as long as x is greater than that number, okay, we don't have to check any further, right? All right, so you see we've already got into this range here. So if x is greater than or equal to 34, there's no solutions. There's not going to be any more solutions because this object would be negative, right? So we don't have to check any further than 2. I hope that was convincing. You can check it if you want to, but you'll see that you don't get a solution. But it's because of this statement right here. This would always be negative, right? This would always be negative, and a negative valued expression never can equal to a positive floor value. Okay, so this is the only solution. Okay, x equals 29 over 4. Thank you for viewing.